Mm, Hello, these are the variables. These ones, as you can see, we have the array, the num, that's the number that we want to search. Then when we are searching using binary searching, you have to know that we have to compare the elements on the first iteration against that of the middle. Then to find the middle, the last end, and the first indexes are very important. Then that's why I'm using first, last, and middle variables on this one. So let's assume these elements are inserted from the keyboard. So to insert the elements to the keyboard, we will use these commands. Already we know that. Then using this way, the array have a size of 6. I mean size of 5. Then we have to insert using this for loop. Obviously we know how it works. Then the next one, this deals with inserting the element to be searched from the keyboard. Let's insert the element that we want to search from the array, whether it exists or not, using binary searching technique. So for doing this one, we have to know that the first index of this array is 0, always 0, because we are too much familiar with the arrays. Always index of the array starts from 0, then that's why I'm assigning 0 for this variable. Then since the array have a length of 5, then it will goes to index of 4. That's why the last index would be 4. Then now we have to find the middle. The middle will be calculated using this way: first plus last divided by 2. That would be the middle. Since that's integer, it is always an integer. Then you have to know that what are integers. So we will use the while loop. While first is less than or equals to last, then if array of the middle element is less than one of the num, the number that we want to insert, that we want to search, then we will go to the left side. If array of middle, if the middle is less than one of the num, then on this one the middle is less than the middle value of the array is less than none of the num value, the element that we want to search. Then from this one, what we have to understand, we can easily we can go to the right sub array of the array. So in order to that, middle plus 1 will be the first, whereas the last will be 4. See, then first assigns middle plus 1, previous middle plus 1, then else if array of the middle matches with the num, say out the num found at position index plus 1, index plus 1, index or middle plus 1. Then if we find, we can say break, then else if, then else of that last assigns middle minus 1. If middle array of middle is less than that of num, automatically we will know that the element to be searched will be existed on the left side of the array, or the left part of the array. That's why we make it last is equals to, or last assigns middle minus 1. So middle will be calculated using this way: middle of that sub array, middle assigns first plus last over 2. Then we will check against none of this one, Then by doing this, if first greater than that of last, which is the end, then we can say the number known is not found in a given array. You see? Or the number is not found in this array. The number is not found in the array, in the array, That is, then finally we can say cout indel, then return to 0. In this way we can build our programs. Then finally we can say, we have to say save, then we have to build, then it says no problem, successful, then it goes to this one, then it goes to run. Let me check. To enter 4, because binary searching needs sorted elements, then 5, 6, 8. But now I want to search 8. Then that is at the end position, at position A. 5. Or we can say this one. Let's run. Eight, 24, 26, 27, 28. You see? Then let's say 30. Then it's not found in the array. And that's why in this way the binary searching works. In general, when we deal with binary searching, always the elements must be sorted first. If they are not sorted, we have to sort first. Then after, on the first iteration, we will compare the searching element against that of the middle element of the array. This is the only character, that the only logic that we have followed during developing a searching algorithm using binary searching. Then see you next